Hello guys, it's me Teacher Hanji and welcome to Teacher Hanji's channel. So for today's video, we will determine the equation of quadratic function given its graph. So let us have our first example. Determine the equation of quadratic function using its graph. Let's say that this is the given graph. And to find the equation of this one, we will be using the vertex form or the standard form of quadratic function, which is y is equal to a times square of x minus h plus k. Since we know that hk here is equal to the vertex of the given graph of quadratic functions, then we will be using the points of vertex to find the equation of these functions. Next, find the values of a to complete the vertex form or the equation of the functions. So from here, we will be using any points from a given parabola aside from the given one. So you may choose any points that you want. So for now, let us find the vertex of this graph. So the vertex or the turning point of this parabola is at point 1, negative 9. So from here, let us substitute it to our vertex form, which is y is equal to a times the square of x minus 1. So I replace h by positive 1 according to the points in our vertex, plus negative 9. And negative 9 is the k according to the given vertex. So let's simplify. So we have y is equal to a times square of x minus 1 minus 9. Now, from here, let us now identify the value of a. So, to identify the value of a, we just need any points from our parabola. So, just pick any points that you want to be substituted to our equations. But for now, I will be using the original given, which is at point 2, negative 8. So, since we know that x here is equal to 2 and negative 8 is equal to 1, let us substitute it to this equation. So, we have negative 8 for the value of y is equal to a times square of 2 for the value of x minus 1 minus 9 from the given equation. Now, simplify this one. 2 minus 1 is equal to 1 square. And 1 square times a will be a. Therefore, we have negative 8 is equal to a minus 9. So, we need to isolate a here since we are looking for the value of a. Then, using addition property of equality, let us add positive 9 to the both sides of the equation. From here, negative 9 plus 9 will be equal to 0. And negative 8 plus 9 will be positive 1. Therefore, the value of our a is equal to positive 1. Let us substitute it to our equation. Here, we will replace a by positive 1. Then our equation will be y is equal to square of x minus 1 minus 9. No need to write 1 for the value of a. It will be an invisible 1. So here, this is now the equation of this graph. Let us have another example. Equation of this graph. Again, we will use the vertex form to find the equation, which is y is equal to a times square of x minus h plus k. So, to get the value of h and k, let us locate the vertex. And for a, let us choose any points from the parabola. So, from here, the vertex will be this one. I just add additional points to our parabola. But if the points is given to the given table, you can use that one to identify the value of a. So the vertex is located at point 1, 4. So let us substitute that vertex to our hk. So we have y is equal to a times square of x minus 1 for the value of h here, plus 4 for the value of k. So at this point, let us identify now the value of a. Let us pick one point from our parabola. So for now, I'll be picking the points in the y-intercept, which is 0, 3. Since x is equal to 0 and y is equal to 3, let us substitute it to this equation. So we have 3 is equal to a times square of 0 minus 1 plus 4. And 0 minus 1 is equal to negative 1. which is negative 1 square is equal to 1 times a will be a. So we have 3 is equal to a plus 4. Using addition property of equality to isolate a here, then we need to add negative 4 to both sides of the given equation. So we have 3 minus 4 is equal to a plus 4 minus 4, which is 4 minus 4 will be equal to 0. That's why our a will be equal to negative 1. Now that we know the values of a, substitute it to our equation. From here, it will be y is equal to negative times square of x minus 1 plus 4. And this one is the equation of this graph. If you notice our a is negative, then the graph opens downward. Let us see our third example. Same, we will be using the vertex form to get the equation of that graph. And we need the vertex to identify the values of h and k. So our vertex is located at point negative 5, negative 4. Substitute it to our vertex form. So we have y is equal to a times square of x minus negative 5 plus negative 4. Simplify this one, the answer will be y is equal to a times square of x plus 5 minus 4. So from here, let us find the values of a by picking one point from our parabola. So for now, I'll be using the points in x-intercept, which is negative 7, 0. Substitute negative 7 and 0 to our equation. So we have 0 is equal to a times square of negative 7 plus 5 minus 4. Negative 7 plus 5 will be equal to negative 2. And 0 is equal to a times negative 2 minus 4 is equal to 0 equal to 4a minus 4. Using addition property of equality, just add positive 4 to both sides to make 4a here isolated. So we have 4 is equal to 4a. Since a here is still a coefficient 4, then divide both sides by positive 4. Therefore, the value of a is equal to positive 1. So from our second equation, substitute positive 1 here. Therefore, the equation of this graph is y is equal to square of x plus 5 minus 4. Again, no need to write 1 here since 1 is number in this equation. Next, for the last example, let us find the equation of this graph. Using the vertex form y is equal to a times square of x minus h plus k, let us get the points in our vertex. So our vertex is located at point 1, 1. Then substitute it to our vertex. So we have y is equal to a times square of x minus 1 plus 1. And from here, let us identify the value of a. So I'll be picking any points from this parabola. So I'll positive 3 and negative 3. So from here, let us substitute it to our equations. So we have negative 3 is equal to a times square of 3 minus 1 plus 1. And 3 minus 1 is equal to positive 2. And 2 squared times a is equal to 4a. Therefore, we have negative 3 is equal to 4a plus 1. Using addition property of equality, let us add negative 1 to the both sides of our equations. We have negative 3 minus 1 is equal to 4a plus 1 minus 1. Simplifying that one, the answer will be negative 4 is equal to 4a. Since we still have here coefficients for a, divide both sides by positive 4. So we have a is equal to negative 1. Since we know the value of a now, substitute it to our equation. Therefore, the equation of this graph is equal to y is equal to negative times square of x minus 1 minus 1. So that is how to find the equation of quadratic function using its graph. Just find the vertex and pick any points from the parabola, then substitute it to the vertex form, and the final answer will be the equation of that functions. Thank you for watching. You're doing a good job. See you again in my next video. Bye!